So another important component are diodes. We're going to talk about two different types of diodes. Just general diodes. There are several varieties, but we'll just talk about general diodes plus LEDs, which LED stands for light emitting diode. Right? So that's also a diode. It just emits a light when current flows through it. So the schematic symbols for diodes and light emitting diodes are shown up there. On the left side of the slide, you see the regular diode. And then next to it, you see the light emitting diode. It looks like a regular diode. It just has two little arrows going out to show that light is being emitted. And then actually next to that, I have a little picture of an LED, right? It's just a typical LED, standard looking LED. And the diodes can look lots of different ways, but an LED typically looks like what we're showing there. Now, an LED or any diode at all, LED or not, has two terminals, an anode and a cathode. Now, the anode and cathode so the thing about diodes, the unique thing about diodes, is they are semiconductors, and current can only flow one direction through a diode. So it's got to flow from the anode to the cathode. It can't flow from the cathode to the anode. Now, even that said, it can flow from the cathode to the anode, but only if you drive it with a lot of voltage. Okay, at the levels that we're using, current is only going to flow in one direction, from the anode to the cathode. So it's like a one-way valve in terms of water, right? It goes one way, it doesn't go the other way. So the LED, if it's an LED, a light-emitting diode, then when current flows, the light emits and it gets bright. Otherwise, it's dark. Now, every diode has what's called a threshold voltage. So let's take the picture on the left side, okay, the forward bias, the one that's labeled forward bias. So notice that the anode is labeled with a plus sign, and the cathode is labeled with a minus sign. So what that's saying is that in order for this diode to be forward biased, meaning a forward bias is when current is flowing through it, okay? The anode has to be have positive voltage with respect to the cathode, okay? So the anode-cathode voltage must be above a certain threshold. So not only does the anode have to be positive with respect to the cathode, the difference between the voltages at those two ends has to be above a threshold. Let's say 1.7 volts, but this is going to depend on the diode. So you'll have this threshold, and if the voltage is below that threshold, then current will not flow. But once it gets above that threshold, then current flows and there's very little resistance. Now, so you see on the left side, we've got forward bias. On the right, we've got reverse bias. Reverse bias, we took the anode and made it negative with respect to the cathode. In reverse biasing, we will get no current flow, typically, until the difference in voltage is so large that it overcomes the reverse bias. So eventually, if you drive enough current, if you push enough voltage, if there's enough voltage difference between the cathode and the anode, you will get current flow, but not at the levels that we're dealing with. Okay, you'd have to have a lot, and we're not going to do that. So reverse biasing it for us will be no current flow. Okay, only in forward bias condition, when the anode is positive with respect to the cathode, and the anode cathode voltage difference is above the threshold, only then will current flow for us. So yes, reverse bias when the anode is negative with respect to the cathode. Another property of diodes is that they have a current limit. So they have some maximum current, and you should not drive them with more than that current. You can probably push it a little bit, but it will wear down more quickly. And if you drive too much current, it'll just blow up and it'll never work again. When I say blow up, it might pop, and you just will never see it working again. So, like typical LEDs that I use, 20 milliamps is the current limit. So, and actually, this is also the limit for the LEDs in your kit, if you got the kit. The LEDs in your kit, typical current limit is 20 milliamps. If you drive it with you push more than 20 milliamps through it, it will die pretty quickly. So do not connect an LED directly across a 5-volt supply. So what I mean by that is, there's the anode and the cathode. If you take the anode wired directly to 5 volts, the cathode wired directly to ground, you'll have a circuit, and current will flow. But a lot of current will flow, because that LED has very little resistance when it's on, right? Very little resistance. And remember, V equals IR, right? So I equals V over R, and the resistance is low, so I will be very high. So, that's the type of situation where you need to, if you want to figure out the type of resistor that you want to put in there in series with the diode, you have to figure out what the on resistance of the diode is, which should be in a data sheet. And then you say, okay, that plus some what size resistance would keep the current less than 20 milliamps. And you can solve for that using Ohm's law. Yeah, and you'll get too much current without a resistor at all. Thank you.